Hello folks, thank you so much for watching my videos. Today I brought one more interesting concept which is .NET Listener for MongoDB. So in this video we are going to see how to configure MongoDB which supports .NET Listeners. Then we are going to create a .NET Listener service which reacts to MongoDB updates like inserts, deletes, and updating a MongoDB collection. So this video is going to be very simple, practical, and powerful. Keep watching. So as I recently started a Docker video series, this is one of the video on the Docker series, and all my video tutorials are going to be real-time scenarios and hands-on implementation. So in this video also we are going to see a real-time implementation and a hands-on video. So before beginning, let's see some definitions and some details. So what is .NET Listener for Mongo? So a .NET Listener for MongoDB typically refers using change streams via the official MongoDB driver NuGet package. This will monitor real-time data changes in a database or collection. It allows a .NET application to subscribe to data modification events, inserts, updates, deletes as they happen. So in simple terms, you can have a MongoDB collection and you can have a .NET service. So this .NET service, it reacts, it listens to the MongoDB collection. So when you insert a new document or when you update a document or when you delete a document, this .NET listener is going to get a notification and it will see what changes you made. So basically, it's a kind of like trigger. If you're talking in terms of SQL Server, but in .NET, like if you are working on any queue messages, like any services which are listening to queue, so this is going to be same. Your .NET service is going to listen to your Mongo collection. So there is no queue required here. So let's see more about the .NET Listener. So what are the advantages of .NET Listener for Mongo? A .NET Listener for MongoDB using change streams or event subscribes provides real-time data synchronization, audit logging, and reactive application updates, enabling applications to respond instantly to database changes. It offers deep visibility into driver performance, such as tracking connection pool health, command execution times, and server heartbeats. So the advantage what I see here, you can now define .NET listeners, .NET services. Instead of those services listening to a service bus or a Kafka topic, they can listen to your Mongo collection directly. So when there is an update, when there is a new record, your .NET service pick those new records and you can do the background process and you can either insert data into new collection or you can send this message to any Kafka. So basically when there is a new update into your Mongo, your .NET listener, it will see those changes and you can process them. So here we can avoid using any service bus or any Kafka topic if you are listening to your MongoDB collection. So how can we do this? There are two steps. First, you have to define a Mongo instance in the Docker. I'm using Docker using a replica. If you are if you are allowing your Mongo collection of listener services, then you have to define um, the MongoDB instance using a replica. I'll show how to do that step by step. And then you have to define a .NET service using the change stream event and listen. So in the previous slide, I mentioned a replica in Mongo. So what is a replica set in Mongo? A MongoDB replica set is a group of Mongo instances that is called nodes that maintain the same data set, providing redundancy, high availability, and fault tolerance. It consists of one primary node that receives all write operations and multiple secondary nodes that replicate the primary's data. If the primary fails, an automatic election promotes a secondary to a primary. So basically, when you are defining a MongoDB with replica set, a primary node will be defined and multiple secondary nodes will be defined. So all your changes will go to the primary and they will be replaced to your secondary as well. So the advantage here, if you will not lose the data. If your primary node fails, you will still have your secondary node. So this is like if you are working on deploying multiple services. So one primary service will be there and multiple secondary services will be there. All will have the same information. If one of the primary service fails, so remaining secondary services, they will elect one of them as a primary. So basically, so the same we are doing in the MongoDB if you are defining a replica set in it. So when you are defining .NET Core um, listeners for MongoDB, you have to define the MongoDB as a replica set. This is mandatory. So why it is mandatory? See the details. Using a replica set when defining Mongo collections in a .NET applications is necessary to ensure high availability, automatic failover, and data integrity, particularly for production environments. Specifying the replica set name in the connection string allows the .NET driver to discover all the members of the set, enabling it to automatically reconnect to a new primary if the current one fails, thus avoiding downtime. So basically, when you are when you are specifying a MongoDB as a replica set, you are trying to define the primary service and the secondary services. So because um, when in this event driven model, the events are very important. If you miss the events, you will lose the real time data. So that's why they are making sure this kind of setup is mandatory. The replica setup is mandatory when you are trying to define .NET listeners for the MongoDB. So how can we define a MongoDB with replica set? So this is the Docker file um, when you're trying to define a MongoDB with replica set. So here the image and container name and these are the ports it's trying to listen. And this command specifies it's using the replica set. So replica set rs0, that is the replica name we are trying to do, and we are binding all the IPs. Then so this will go into the sleep mode for 5 seconds, and then this will evaluate whether the replica get created on this local host or not. So let's run this uh, Docker Composer and see how the Docker instance get created, and then we will see how to connect it by using the Studio 3D. So let's run Docker Compose up -d and see how the containers get created. So it's pulling image for the Mongo 7, the version we mentioned here. It's still pulling the image. And once it, so then the network details, and also it created a container naming it as a Mongo RS and it started it. Let's see on the Docker front. So this is the Docker. You can see the green. So it's perfect. Go to the containers. Yeah, you can see it's green. So I think it's working fine. So there is a way you can verify whether the Mongo it's working or not. Let's see in the command prompt. So in the command prompt, you can check whether the Mongo uh, it's working or not. So docker exec -it mongo rs, that is the container name, uh, mongosh evaluation rs status. You should see something uh, like OK equal to 1 that says it's running, and even the state it's a primary. So as I mentioned, there are multiple nodes, primary and secondary. So it's stating that the primary is working. So this is the indication that the replica set is working fine, and also the OK equal to 1. So now I think we are good to go. We will open the Studio 3D and we will see how to configure it. When you are using replica set, there is a little different way you have to do the things at Studio 3D as well. Let's open the Studio 3D. There are different ways you can create a connection in Studio 3D. In the previous video, I have shown by using the UI, but let's use the URL. So MongoDB colon localhost, this is the port name, port number. And here, if you are using replica set, you have to pass the replica set and its name. So the replica set name is rs0. I'm going to use that. Click on next, which will again open the UI only. So this is rs name. If you want, you can give Mongo listener. So local sources, and this is the members, and here the connection type is replica set. Earlier I used standalone, but now I'm using the replica set. And then what is the replica set name and which node you're trying to use, the primary, and just test the connection. So it's working fine. I think you can save and connect. So this will open uh, your local instance. And here I already created few collections, uh, database, demo DB, and customers, orders, and products. Now we are going to listen to one of the collection. Let's say it's a order collection. We completed defining our MongoDB, which supports .NET listeners. Now we are going to create a .NET service, a console, a .NET worker service. This is called a worker service, so which listens to uh, the Mongo collection we created. So let's create it. .NET a new worker. We are going to create a worker service, and we call it as a order listener. So just run this command. It's going to create a new worker service in the .NET front, which listens to the collection. Yeah, it restored few packages, and then it's created the .NET worker service. And now we have to navigate to the folder, and we have to install the Mongo drivers. So this command will add install MongoDB drivers. Let's run this. Something went wrong. Yeah, I missed .NET in the beginning. So just add .NET space. Yeah, so this command added MongoDB drivers, the NuGet package. So now we are good to go and use various classes, objects in the MongoDB driver. Let's write the code. So first define a model which represents the collection. So create models, name it as models, then add a new model object and name it as order.cs. just replace, yeah, and yeah, these two namespaces got added. So it has an order ID, customer name, amount, status, and created it. So let's make some changes to the worker, the default worker. So if you closely, this is the default worker process get created. And if you closely observe this, so this is the worker and which inheriting from the background service. This background service, it will be there in the uh, Mongo. Um, no, it's a Microsoft extension. So it runs as a background service, and it defined a iLogger and a constructor and a execute asynchronously method. So now we are going to make some changes to the um, constructor so that uh, I can have the Mongo connectivity. So for Mongo connectivity, um, so what we're going to do, first define a private variable here. So first define the Mongo connectivity. So read only I Mongo collection, um, which is order collection. You have to use the orders. So then here I'm going to create a client, Mongo client. But this Mongo client, we have to use the same URL uh, uh, what we used for the uh, what we used to connect to the Mongo Studio 3D. So it will have the URL and replica set as its name, and then you can connect to the database. So here you can specify the data, and then you can get the orders. So here order collection database dot orders. So if you are using uh, different names or different connection string, you can change this, but this will establish the connection, and it's going to listen to the collection in the Mongo. I updated my execute asynchronous method to uh, do the job for my collection. So here it's logging the information. Then this pipeline, it's going to tell what kind of changes you are listening for. So it's going to, if there is a insert to the collection, if there is an update to the collection, or if there is a replace to the collection, this pipeline is going to be notified. So this watch asynchronously. So this is the pipeline I'm building. So these are the changes it's going to listen for. And so here I'm deploying that pipeline, so which watches asynchronously. So if you see here, it's taking the pipeline and cancellation token and stopping token. So this is going to build a pipeline which listens to your MongoDB collection. And when there is a change, this uh, code will be getting those changes and it will be having that information. So before that, we have to register this worker in the program.cs. Go to program.cs. So I updated my program.cs and I registered my worker service. So now the order worker service is ready to run um, and listen to the topics. Sorry, listen to the collection. So I put a breakpoint here and now I'm running this code. So it will execute this code. We'll go step by step. Um, so this pipeline is building. It's constructing the pipeline, and it's deployed so that um, this service, now there are no changes. So this is going to execute in a loop. So for every five seconds, we gave a 5 second, right? So it will wait for the 5 seconds and it will check. So now how to how to kick the events into your Mongo collection. Let's open the Mongo collection in Studio 3D and insert a record. So this is my um, Studio 3D. I opened up the orders collection, right click, insert a document. I gave a customer name, test user, amount 99, status created, and created date. So once you add this document, uh, the listener should see these changes and it should uh, execute this for each loop. Let's see that. I'm done, and immediately it identified those changes. And this is the complete change object. You can see a lot of information, the backing document, etc., etc. But here we need the full document. If you open the full document is nothing but whatever document you inserted there. So it's going to see amount 99, created it, customer name, ID. So I did not write any code, just I'm logging this information, but you can uh, catch this document, the complete change dot full document, and you can process it. Either you can use this data to get some more data from other collections and update this data into some other collections, like whatever process you want to do, you can do that. So yeah. So you can see the console change detected. So which is insert document ID. It's showing its ID, customer name, test user, amount, like whatever I have shown in the debug mode. Everything you can see here. Now let's see whether our update is identifying or not. So the insert um, event is working. Let's see how the edit or update is working. So I open the document, test user updated. I'm going to use 98, and here I'll update this to updated. Once you click on this update, it's going to update the document in uh, Mongo, and also it's going to notify the .NET listener. So let's do that. So yes, it updated the .NET listener, and let's open the change object and see what uh, we have. So when the change event is update, the document we are receiving here, it has a little different information. So if you see, the full document is null, because we don't, in case of insert, the whole document is no. That's why the full document has its value. But here we don't need all the fields. So it will show like whatever the updated fields we have. Let's see where we can see that information. So in change event, we have backing document. Open the document and open the elements, and here you can see update description, updated fields. Amount got updated to 98, customer name got updated to so and so, and status get updated to so and so. So it's only giving the updated fields. Um, so the elements get updated are 3. And did we remove any fields? No. If you remove any fields, it will uh, show here. And if we truncate any arrays, it will show here. But here, if you want to see process the changes, come here and get these elements, and or else you will have the ID. So ID of the document, you will have it. With that ID, you can retrieve the entire document if you want. So in case of updates, so the change detected was type of update. The document is null because we are Uh, in the logging information, we are trying to display the full documents. That way you're seeing empty, but you can get it from the um, other place in the change object. So that's it. I think the we are done with defining the listener and see the real-time updates. So when there is a change here in the collection, your service is going to notified and it will get all the required information so that you can use that information for further processing. Yep. Just now we finished our .NET listener service for MongoDB. So as part of this video, we have seen what is Replica, what is the advantages of using Replica, and why it's mandatory when you are defining a MongoDB for open for .NET listeners or any listeners. And then we have seen how to configure MongoDB in the Docker with the Replica set, and how to configure the connection in the Studio 3 team. After that, we gone through how to create a .NET worker process, and then establish a connection between your Mongo collection and your .NET service, and how to configure the service, how to build the pipeline for which events your listener is targeting, like update, um, delete, and insert, update, and replace. And finally, we have seen how your .NET service is getting notified when there is a change in your Mongo collection. When you are inserting data into Mongo, when you are updating a document in Mongo, how it's in reacting, how it's notifying to your .NET listener, and how you are getting information like what has changed. Thanks once again for watching the entire video. Please provide your feedback. I hope the topics are uh, more useful and more informative. Let me know if you need any specific topic. I can make some time and create the video. Thanks again. Please provide your feedback in the comment section and share, um, like, subscribe. Thanks again. Happy coding.